Hello students, I hope you all are fine. Students, as you know that we have started unit 8, that is the redox reaction. In that unit we have discussed about the oxidation products, oxidation process, redox process and redox reactions also. And balancing also we have covered there. So today we will discuss about the electrochemical shell. Okay, first of all you should know about that what is the electrochemical shell. Electrochemical shell. Students, by name, you can understand by this concept. Electrochemical cell is that cell which is used to convert chemical energy into electrical energy, You know, it is a device. Electrochemical cell, it is a device which is used to convert electrical energy into the chemical energy into the electrical energy. That type of device is known as the electrochemical shell. Clear? Then students, we will do the construction of the electrochemical shell. For construction of the electrochemical cell, we take two containers. One is this one. Okay? And come beta. We will take two containers, students. In one container, we will fill 1 molar zinc sulfate, and in second one container, we will fill 1 molar copper sulfate. Then students, we will dip metal rod in both of the containers. Here we are taking zinc sulfate, so we will dip the rod of the zinc here. We will dip the rod of the zinc. And students, in this container we are having copper sulfate. So we will take rod of copper also. Copper rod we will dip. Then students, both of the rods we will connect with a wire. We will connect them with a wire. And students, in between we can connect either one bulb or we can connect galvanometer also. Clear or not? I think in book galvanometer is given there, but you can connect with any ammeter, you can connect with bulb also. Okay? Generally, you will construct like this. Now, you will see how here we will convert the chemical energy into the electrical energy. Means we will produce electricity here. Okay, so how can we produce? You will see that. Students, actually what will happen if these two containers are not connected with one another? If these are not connected, let us consider they are not connected with one another. Then students, no reaction will be there. Why? Because you know very well about the displacement reaction. What is the displacement reaction? Displacement reaction is that in which more reactive element replace the less reactive element. More reactive will replace less reactive. But students, you can see, if I am having zinc sulfate solution here, this solution is known as the electrolyte. Electrolyte means which can conduct electricity through them. Conducting solution it is. And students, here zinc rod, these are known as the electrodes. These metal rods are known as the electrodes. You know very well there are two type of the electrode, anode and cathode. Anode and cathode, but now I am not talking about this one is the cathode, this one is the anode. Okay, we will see on behalf of their working which one is anode here and which one is the cathode here. Okay, so these two rods are the conducting rods. They can pass current through them, so they are known as the electrodes. They are known as the electrodes. One of them is anode and one of them is cathode. Which one is cathode, which one is anode, we don't know about that till now. Okay, but we will able to identify. Then students, here zinc rod and zinc sulfate, both metals are same na. In solution also zinc metal here, and metal rod is also made up of the zinc. So both have same reactivity. Both metals have same reactivity. So they will not replace. No one will replace one another. Okay, means no reaction will take place here. And same reason is here. Here both copper sulfate means solution of copper here and rod of copper here. Both metals are the same. Both metals are same. Means they will not replace one another. Further, they will not replace one another. But students, if we connect both of the rods with wire, and here I am taking one bulb, then what will happen, students? Then what will happen? Let's see. Then students, this bulb start to glow. This bulb will start to glow. You can observe, we are not using any shell, we are not using any battery, we are not using any switch here. But when we connect both of the containers, both of the metal rods, then these bulbs start to glow. Means electricity production is taking place here. Electricity is produced here. So how does it flow? How does it flow? Students, what will happen? Actually, you can see this zinc rod and this one is copper. We have connected them. And you know very well, zinc is more reactive. Zinc is more reactive than copper. Zinc is more reactive. If you are writing the symbol and the symbol has two letters, then first one you will write capital and second one in small letters. Okay. Here students, zinc is more reactive than copper. So zinc can replace copper. Zinc can replace copper. What will happen? This will lose its electron. This will lose its electron and it convert into Zn2 positive. In ionic form it convert. Plus 2 positive charge here means it is losing 2 electrons. Clear or not, students? These 2 electrons will flow from this wire. Flow of electron will take place here. And students, here what will happen? These CuSO4 means CuSO4 means Cu2 positive, SO4 2 negative. I can write in this way or not? Okay. So these copper ions will gain these electrons, the electrons which are coming from this, which are passing from this wire. Okay. These electrons gained by the copper ion, and ion will convert into the metal. Ion will convert into the metal. Okay. Then students, you can see flow of current is taking place here. Why? Because flow of electron is taking place here. Flow of electron. And why electrons are flowing? Because here metals have reactivity difference. Zinc is more reactive as compared to the copper. So zinc can give their electron, can donate, can release their electron to the copper. It is clear to you or not? Then students, this zinc will lose its electron, and these electrons are gained by the copper ions. Okay. Then students, this setup and this process will be continue only for a small time. It will be continue only for a moment. After some time it gets stops. You know, ये जो हमारा सेटअप है ये लंबे टाइम तक नहीं चलता. It doesn't run for a long time. It gets stopped after some moment only, after some time only. Why does it happen? Students, what will happen? Here you can see continuously this zinc rod will lose its electron. Okay, and zinc metal convert into the zinc ions. Then what will happen? Here already ZnSO4 is present. Means Zn2 positive and SO4 2 negative ions are present already. And students, further formation of Zn2 positive ions is taking place here. Because continue, this metal rod is losing its electron. And after losing the electrons, it is converting into the Zn2 positive ions. Means more number of positive ions are producing into the solution. And students, at a time, concentration of positive ions will increase and they start to repel each other. You know very well, same charge will repel each other. Okay, students, already it is present in the ZnSO4, means in salt form. Already same number of zinc positive ions and SO4 2 negative ions are present here. It was neutral, but after reaction, this zinc rod is also losing its electron, and after losing the electrons, it is converting into the ionic form in Zn2 positive ions, and these Z positive ions are remaining in solution now. So here concentration of cations increases. Concentration of positive ions increases here. So positive to positive ions, they start to repel each other. And here also students, here what will happen? Here continuously copper sulfate means Cu2 positive and SO4 2 negative. These ions are present. These copper ions are gaining electron continuously, and they are converting into the copper metal. At a time, students, maximum copper ions get converted into the copper metals. Clear? Now what will happen? Continuously, because it is losing its electron and it is converting into the Zn2 positive ion. Then students, here concentration of Zn2 positive ions increasing into the solution, but this rod start to decay. This start to become thinner beta, because continue metal is converting into Zn2 positive ions, and these Zn2 positive ions comes into the solution. Okay, so continuously it become thinner. And here what will happen? These copper ions which are present in solution, they gain electron and they are converting into the copper. So this here deposition of the copper take place on this rod. Deposition of copper take place on this rod. Okay, so it become thicker. It become thicker. Here deposition take place, but it get deflected. It is depleting according to the time. With time it is depleting and here deposition take place on this one. So it is becoming thicker as compared to the first moment. Okay, then students you can see here copper ions are converting into the copper metal. So sulfate ions are increasing here. Only sulfate ions are remaining here. Then negative ions will also repel each other. They will also repel each other. Clear or not? Then students, due to this region, this setup work only for a moment, only for some time. After some time, it get stop to work. It stop to work. Then students, what we can do that it does the work in continue manner. It does the work in continue manner. What can we do for that? Clear or not? Then what will we do, students? Here we will insert a U-shaped tube. We will insert U-shaped tube. This U-shaped tube is known as the salt bridge. Salt bridge. We will insert an U-shaped tube. And this U-shaped tube is known as the salt bridge. Okay, and we will insert in inverted manner. In inverted manner means उल्टा करके हम उसको रखेंगे. Clear or not? And students, we will fill either KCl, either KNO3 or K2SO4 in this inverted tube, in this salt bridge. We will fill this solution of potassium chloride, solution of the potassium nitrate or the potassium sulfate. These electrolytes we will fill. Why? Because students, they maintain the neutrality. They maintain the neutrality of this setup. Clear or not? And students, they does not affect the concentration of ions here. Concentration of ions is also not affected by this solution, and they can make neutrality also. They can maintain the neutrality of the solution also. Then we will fill the electrolyte of this one also. Clear or not? Why? Because potassium is the highest, it is the most reactive metal. So it cannot be replaced by others. It cannot be replaced by the others. Clear or not? So it will not affect the concentration here. And students, we will fill some solution like gelatin, like agar-agar solution in this tube. Why does? First thing, we will fill electrolytes. We will fill electrolytes like potassium chloride, like potassium nitrate or potassium sulfate only. Why? Because they do not affect concentration present in solution. Clear or not? And student, they maintain neutrality also. They maintain neutrality also. Okay. And students, we fill agar agar and agar and gelatin gums like this also. Why? Why we do this? Because students, these are the semi-liquids. These are the semi-liquids. Students, just think. Here we are putting this tube inverted. उल्टी करके हम रख रहे हैं. If we are having liquid only, then it can be maintained in this one. Not now. So we will fill some semi-liquid into this one. Means it will be remain here and we can put some cotton pulp here. Clear or not? इसीलिए कि इससे बाहर इधर नीचे ना गिरे, इसमें मेंटेन रहे, उसी के लिए हमने यहाँ पर ये सेमी लिक्विड लिया है, कंप्लीट लिक्विड नहीं लिया है. It is clear to you or not? These are the jelly like, you know, these are the jelly like. So they can be maintained in this tube. So we are filling this one. Then students, what will happen? What will happen if we are having the salt bridge? Then students, if positive ions concentration is increasing here, then like we are taking potassium chloride only, then chloride ions can maintain neutrality here. Clear or not? If students, here sulfate ions are increasing, then potassium ions can maintain neutrality here. Clear or not? So students, this salt bridge is used for maintaining the neutrality. It is used for maintaining the neutrality. And after setting this, it will work continue. It will work in continue manner. It is clear to you or not? Then students, we have done construction. How can we construct the electrochemical shell? In electrochemical shell, we take two containers. In one container, we will fill 1 molar zinc sulfate, okay, and in one molar copper sulfate. Here we are having zinc sulfate, so we will dip the rod of zinc. Here we will dip rod of the copper. Okay, then students, if we are not connecting them with wire, then no reaction will be there. But if we are connecting a wire, then this bulb will start to glow. If you are having the galvanometer, then there will be any deflection. There will be deflection. So that deflection will show current is flowing or not. If you are having ammeter, then it can also show the passage of current. Clear or not? So simply I am having bulb only. If it is glowing, means electricity production take place here. If it is not glowing, means it is not taking place here. Clear or not? So students, current flowing taking place from this to this rod. But here, sorry, it is flow of electron. Flow of electron taking place from zinc rod to copper rod. And here, from copper rod to zinc rod, flow of current take place. Flow of current take place. Conventional current will be flow in opposite of the electron. In opposite direction of the electron. Now students, we will see which one is anode and which one is the cathode here. Now you have understood all about the constructions and working also. Now students, see here, this zinc is losing electron. This zinc is losing electron. So students, loss of electron is known as loss of electron. loss of electron is known as oxidation. You know very well now. Oxidation. Some basic thing I'm going to tell you. Always students, oxidation will take place at anode. Anode. Till now, you are understanding in this way. Negatively charged electrode is the cathode. Positively charged is known as the anode. But it is not true at all time. Now you will change your definition. Up to 10th level you were studying that. Negatively charged ion is the negatively charged rod is the cathode. Positively charged rod is the anode. But now change this one, students. The metal rod at which oxidation takes place, that is known as the anode. That is known as the anode. And the metal rod at which reduction takes place, is known as the cathode. Is known as the cathode. It is clear or not? Yes. Now students, you know very well. What is the oxidation? Oxidation means loss of electron. Oxidation means loss of electron. Loss of electron. Okay. And here reduction means gain of electron. Now you can see here at this one, production of electron taking place here. Okay, so this rod is the negatively charged, this rod is the negatively charged rod. Clear or not? And this one is the positively charged, this one is the positively charged. Production of electron taking place here now. Okay, so it is negatively charged and this one is the positively charged. At this, what will happen? Loss of electron take place here. Zinc is losing its electron. Zinc is losing its electron. And loss of electron is oxidation. Means at this, oxidation is taking place. Oxidation is taking place. Then students, loss of electrons. So at in left hand side, zinc is converting into the Zn2 positive plus losing 2 electrons. Clear or not? And students, here you can see, this one is the left hand side now and this one is the right hand side. Okay, here what will happen? This copper ions are gaining the electron and they are converting into the copper ion. Sorry, they are converting into the copper metal. Then students, at cathode, Cu2 positive, they are gaining 2 electrons and converting into the copper metal. Clear or not? Then students, here at anode, oxidation is taking place. Okay, but this one is negatively charged. This one is the negatively charged metal rod. And here gain of electron taking place. If gain of electron taking place means here reduction is going on. Okay, and this one is cathode because at cathode reduction take place. And this one is the positively charged rod. This one is the positively charged rod. Clear or not? Then students, if I want to write the overall reaction, then what will happen? Here you can see, you will add reactant in reactants, reactant into reactants. Clear? Then student, zinc plus Cu, two positive ions, plus. Students, try to understand. Here, evolution, removal of electron taking place, and these electrons are consumed, are gained by this one. So, can we cancel these electrons or not? Removal of electron taking place here, and these same electrons, this rod is losing its electrons, and these electrons are gained by these copper ions. So we can cancel or not? Clear? Then students, we can cancel these electrons. Now we will add product in products. So Zn, 2 positive plus copper. So this one is the ionic reaction here. This one is the ionic reaction here. And student, generally you know very well, we are having ZnSO4. We are having zinc plus CuSO4. Reaction is taking place between them now. Okay. Then what will happen? This zinc is more reactive. This one is the more reactive. Okay. So more reactive can replace the less reactive. So this zinc will replace this copper. This zinc will replace this copper. Okay. So finally students, you will get zinc sulfate. You will get zinc sulfate plus copper metal. Plus copper metal. So this reaction will happen during this electrochemical shell. Is it clear or not? Yes. But students, in opposite, if you are having in this way, Cu plus ZnSO4, then what will be the product? No reaction will take place. Why? Because copper is less reactive. This one is less reactive as compared to the zinc. So it cannot replace this one. Okay. So today we have discussed about the electrochemical shell. What is this? Tomorrow we will discuss about the electrode potential. Okay, students. So thank you. Have a nice day.